Hello everyone, let's discuss the domain, how to find out the domain and range from the given rational function. So this is a figure given. From this figure, how do we know that what is the domain and what is the range from these figures? Let's try to discuss them. First figure, in this figure, so you see what will be the domain, and you can look at this thing. If you look at this side of the graph, see this side is going to the negative infinity forever, and it is coming closer, and there is some asymptote here at 0, at x equals to 0, which tells us x equals to 0 is not a possible solution for this question. So x equals to 0 is not included here. This red dot line tells us that always if you see any vertical dot line, that means that value we will have to exclude, like this. We have to exclude from the domain. Okay, always this dot vertical line means that. And this side also we have some graphs which is going to the plus infinity in the positive direction, which means our domain will be all real number other than 0, other than this 0. Okay, and range is interesting for this question. As you can see, from this plus 2 to the plus infinity we have the graph. That's why we said y is greater or equal to plus 2. Then from minus 2 is here, minus 2 to minus infinity in the y side, the graph is going. That's why we said y is less than or equal to minus 2. Why we said equal to? The reason is minus 2 is included in the point. Here, plus 2 is included in the point. That's why. So this is how we get domain, means the possible x value which we have, which we will get in the from the graph, and range means possible y value that we can see in the from the graph. No matter which x value we put, we will get this y value from the graph. Okay, this is what it means. This question is, so see what are the our asymptotes here, vertical asymptotes. So there is a vertical asymptote here and there is a vertical asymptote here. We have to exclude this plus 2, this plus 2, and this minus 1 from the domain, and all other values are okay, because see, from this side graph is going to the infinity, from this is going to the negative infinity, and this is going to the positive infinity. I just cropped it. I took the screenshot, that's why you cannot see some arrow sign. There are some arrow sign this side also, according to the graph. And why the range is all real number here? This is actually interesting. Although you can see that there is some horizontal asymptote here, still why our range is all real number? The reason is this line here is actually crossed our horizontal asymptote, and so we have to include this point also in the on the range, which is telling us that all the numbers, all the real numbers, see, from the to the positive infinity to the negative infinity, all the numbers are included in our range. So for this question, this is our range, all the real numbers, and in the domain you can see we have to exclude this value and this value. Other than these two value, all the real numbers are our domain. What about this question? So in this question, see, we have our asymptote at x equals to 1, minus 1, 2, 3, minus 3. So minus 3 we have one asymptote, and plus 4 we have another asymptote, vertical asymptote. So that's why other than these two numbers, we have all the values are okay for this graph, and range is all real number due to this graph. Actually here, this graph takes all the y value. This graph actually takes all the y value. That's why all the real number. Now let me actually say it. There is some interesting implication if we erase this part of the graph. Suppose this graph is not given, this graph here is not given, then what will be the domain? I can similarly say if this graph is not given, then what is the domain? Okay, then domain will be changed. Then domain is not only this and this only. Okay, then we have to give more conditions. Suppose this one is not given. That means our x value will be this value 4, 4 2, then this is minus 3, 4 to minus 3, and 4 and minus 3 is not included. Then again from minus 3 to minus infinity, where minus 3 is not included. That means because this side our graph is blank, so we cannot say that this is included in the graph. We only have to say that this side, this portion here and this portion here is within the domain. Domain means where you can see, according to the x line, where you can see the graph when the graph is given, where you can see the graph. If the graph is not here, suppose graph is already here, if the graph is not here, then what? Then we cannot say that domain is included this value. Similarly, if this side is not given, then we have to say domain is from this number to this number, this entire space between them. Remember, this minus 3 and plus 4, they themselves are not included, as they are the asymptote. We have, what is included then? Included means this space in between them. Then suppose this is given, as I said, now this is not given, only this is given, so then again we will say from 4 to the plus infinity, and that will be the domain where 4 is not included again. So it depends on the graphs. Okay, it depends on the graphs. Where is my graphs, where these graphs are shown in the figure, domain and range, both of the thing is depend, both of the things, they depends on the graphs. Suppose if I erase this part of the graph, then domain will be, a range will be from the plus 0 to plus infinity, if I erase this negative side of the graph. Okay, this is how this domain and range. And look, if I erase this graph, then actually domain will not change. Okay, domain is not doing, domain, this part, suppose if I erase from here to downside, then only and there is some interception here, then this part is also, there is no graph. We have to be careful about that. Of course, naturally, normally our question is not that much deep or that much tricky, like we erase all of a sudden something from the from the middle. We don't do it usually, because we just draw the graph of some functions, kind of that rational functions, and rational functions actually gives us this some regular kind of shape. But just to tell you, just this is the idea actually, this is how that domain and range is range comes from the given figure. Anyway, I hope this domain and range kind of thing helps you in your understanding. All right, thank you all, thank you very much, and bye.